Okay, so now that we have learned about exponentials with a base of e and logarithms or natural logs, log base e, now we're going to learn how to take derivatives of those items. So first one is the derivative of the exponential with a base e. Those are functions that are e to some exponent, and we're going to take the derivative of that function. Okay, so the way we do that, write the function exactly as it appears. Don't change anything, and then multiply it by the derivative of the exponent. The derivative of e to some power is e to some power times the derivative of the power. Okay, so you write it exactly as it appears first, and then multiply by the derivative of the exponent. So let's look at some examples. Okay, so first we have 3e to the x, write it exactly as it appears. And then let's look at the exponent. What is the derivative of x? Well, remember that's 1x, so the derivative is 1. So your final answer is going to be 3e to the x. Okay, on this second one, this one is x squared times e to the x. So we should be thinking product rule. Okay, so y prime, the first, leave it alone, so x squared, times the derivative of the second, so times e to the x times 1, plus the second, leave it alone, e to the x, oops, 1 second, e to the x times the derivative of the first, which is 2x. Okay, and then let's combine things and move them around. So we have x squared e to the x plus 2x e to the x. Yes, I like the numbers in front, so I rewrote it that way. Really, the only thing you needed to do was multiply that 1 in. Okay, so that would be your final answer. On the next page, there are some additional examples for you to do. So take time. Try the ones on the next page, and then check your answers with what I have. Okay, so there are the 3 problems. The bottom one will be a quotient rule. Okay, and you will have to simplify at the end. I believe every term is going to have at least one x that will have to be divided out. Okay, so write those problems down. I'm going to uncover the answers, so you might want to pause this video before I do that. And then you can check your answers. All right, let's try some more. These are a little bit more difficult. So A, we have y prime, write it exactly as it appears, and then multiply by the derivative of that exponent, which is going to be 8. So our answer there is going to be 8e to the 8x. Okay, you'll notice we're not subtracting from the exponent. This is not the power rule. The power rule does not apply here. Okay, on B, B looks terrible, but it's really not quite that bad. So y prime, let's just follow our steps, write it exactly as it appears. We're not even going to think about anything. We're just going to write the same thing down just like it is. Okay, and now we're going to multiply that by the derivative of the exponent. So just the derivative of that, which is going to be negative 2x plus 4. Okay, and really there's not a lot more we can do with that. So that will be your final answer. I'm going to rewrite letter C down here. Okay, so C started out as y equals e square root of x squared minus 3. And first thing, we're not taking a derivative yet. First thing we have to do is rewrite it so that we can take a derivative. Okay, this is not calculus yet. All we're doing is rewriting it in a form that makes it so we can take a derivative. Okay, so these two things here and here are equal, but this second one is what we need so that we can take a derivative. All right. Okay, so y prime, write it exactly as it appears. Okay, and then multiply that by the derivative of the exponent. Let's look at this exponent. Okay, that is a chain rule. So we have 1/2, right the middle, just like it is. Change the exponent here, subtract 1 times derivative of the inside, which is 2x. So we have derivative of the outside, derivative of the inside. And let's see what we can combine. It looks like the 1/2 and the 2x can get multiplied together. So we're going to have y prime equals x. And then we have e x squared minus 3 to the 1/2 times x squared minus 3 to the negative 1/2. Now remember, this one is an exponent. This second one is not. Okay, so that should be your final answer. You could also write it like this. Over and move that to the bottom. Okay. On the next page, there will be some examples again for you to do, and then I will uncover those answers. Okay, so here are examples for you to try. Go ahead, pause the video so that you can write these problems down, and then I will go ahead and uncover these answers now. Okay, so there are the answers to those three. Okay, now we have a business example. So we have Franco's Fishing Emporium. They've invested $50,000 into an account. It earns 1.25% annually. It's compounded continuously. And then we have the value of the account after T years is given by, okay, and we know that was the principal that they put in. This is their interest rate. And we are asked to find A of 5 and A prime of 5. A of 5 and A prime of 5. So let's go ahead. We're going to move to the next page. Okay. Oops, sorry. Actually, let's start it here. We'll do A of 5 here. So A of 5 just means to take the function that we have and plug 5 in. And I believe what we get is $53,224.72. Am I remembering correctly? Okay. Now, this does say to interpret that meaning. So what that tells us is that after 5 years, we have $53,224.72 in the account. Okay, so that's our total balance in the account after 5 years. Let's go and look at A prime. So for A prime, we have, so let's start by A of T was 50,000 E 0.0125 T, and we need to take the derivative. So let's find A prime. Okay, so write it exactly as it appears, 50,000 E 0.0125 t, and then take the derivative of that exponent. We're going to multiply it by that derivative of the exponent, which is 0.0125. Okay, if we go ahead and simplify that, we get 625 e 0.0125 t. Okay, and now we can plug 5 into this one. So we have 625 e 0.0125 times 5. We're going to plug that into our calculator. And I believe what we get is 665.31. Okay, so what does that tell us? We took the derivative of our amount. Okay, that first one, the amount function, gave us the total dollar value in the account at the end of 5 years. So with the second one, what the derivative is telling us is that at year 5, our balance is growing at a rate of $665.31 per year at that moment. All right, the next part we need to do is to take derivatives of natural logs. So to take the derivative of a natural log, we're going to have a natural log of some function. And the way you're going to take the derivative is take 1 over whatever that function is, this piece right here. We're going to take 1 over that function, and we're going to multiply it by the derivative of the function. Some of you might like this shortcut here, where you put the derivative on top, the function on the bottom. Either way is fine. We are not going to worry about substituting. Okay, so let's look at a couple examples. Remember, 1 over the function times the derivative of the function. You'll notice that in these two parts, there's no longer an ln. Okay, there should not be a natural log in our answer unless we have done a product rule or something like that that would keep it in there. Okay, so here's our first one. 5 times ln x is 5 times the derivative of the natural log of x, which is 1 over x times 1. So our final answer, remember tops to tops, bottoms to bottoms. So we're going to have 5 over x. That would be our y prime. Okay, for our second one here, y prime. Now again, this is a product rule. So this one will have a natural log in the answer, but only because we have to write down the second exactly as it appears. Okay, so the first, leave it alone, times the derivative of the second, which is 1 over x, times the derivative of x, which is 1, plus, now we have to do natural log x times 3x squared. Okay, so that's why the natural log stays in a product rule. It's because you have to write down the second as it is. Okay, and then we need to go to that second term. So we have plus 4. And let's see what we can do with all of this. Y prime. So I have x cubed over x, so that's going to just be x squared plus 3x squared times ln x plus 4. That should be your final answer. Okay, go ahead and try 1 and 2 on this page, or A and B, I'm sorry. And I will go ahead and jot the answers down for you. Okay, pause the video if you want to try them on your own and not see the answers. Okay, remember, 1 over, this is for part A. So we're doing this one first. Okay, 1 over 3x times the derivative of 3x, which is 3. So I have 3 over 3x. Those 3's divide out, and I'm left with 1 over x. On B, I have 1 over x squared minus 5, that's the function in here, times the derivative of x squared minus 5, which is 2x. So my final answer on that one is going to be 2x over x squared minus 5. Okay, now I want you to pay attention here. A lot of people will try to cross out those x's. Not everything up there has an x. If I can't take it from everybody, I can't take it from anybody. So since this 5 does not have an x, so I can't take 1 away from the 5, I cannot divide that x out. All right. I'm going to let you try these, and I'm just going to write the answers down for you real quick. So go ahead, pause the video, and write those problems down so that you can do them. And then I will review the answers. All right, so there are the answers for those two. And that is where we are going to finish this lesson. So practice your natural log and e to a power derivative rules. And I will talk to you next video.